All right, we are on the last of the main sections that we want to focus on. There is one more section after this, but it's a pretty straightforward section. So in this section, we're going to talk about order of operations. This comes from section 1.8 of the textbook. Now, before we get into order of operations, we still have one thing left that we need to discuss. Technically two, which is exponents and square roots. So exponents represent repeated multiplication. Inside exponents, we have two numbers. The first one is the base. The base is the number that is being multiplied. So if we look at our example off to the side, 4 is our base, and 3 is our exponent. And so what does the exponent tell us? It tells us the number of bases being multiplied together. So when we talk about exponents, there's 3 different terms that you might see. The first one is exponential notation. Or form. And exponential form or exponential notation means write it with exponents. We also have expanded form, and expanded form means write the problem without exponents. We want to expand it out. So we're going to write it with just multiplication. And the last thing that we have is simplified form. Or evaluate. So if it asks you to simplify or evaluate the exponent, then you need to actually state what is it equal to. Okay, so let's go ahead and try some quick examples, and we're going to go ahead and practice with these different notations and go ahead and evaluate. So if we look at example A, we have 4 squared. If I go ahead and write this in expanded form, this is 4 times 4. And if I evaluate it, my final answer is 16. Example B, if we write this in expanded form, this is 4 3's being multiplied together. I'm going to go ahead and multiply in pairs. 3 times 3 is 9. 3 times 3 is still 9. And if we simplify this, we get 81. Okay, example C, if we write in expanded form, this is 6 2's being multiplied together. I'm going to go ahead and do 3 at a time. 2 times 2 is 4, times 2 is 8, so we get 8 times 8, which is equal to 64. Now, over the course of this semester, I would like you to practice your memorizing your exponentials. If you need to make a table to have them available to you, that would be great. But in the meantime, I do encourage you, even inside problems, to write in expanded form to make sure that you don't make clumsy mistakes. If you say 4 squared is equal to 8, you will get that wrong. But if you write it out as 4 times 4, then at least I know you understand what it means to be an exponent. And the other benefit of writing it in expanded form is you are less likely to make careless mistakes. Now, with exponents, we also have something called square roots. Square root is the opposite of squaring a number or raising it to a second power, an exponent of 2. When finding square roots, you want to ask yourself what times itself results in the inside number. Our notation for square root, it looks similar to our division house, but notice that it does have a little tail on the end. And that is the main thing to keep in mind, is if it does have that little tail on the end, we are talking square root. So let's go ahead and try some examples. Example A, we have the square root of 36. So what I want to know is what times itself equals 36. The answer is 6. Example B, same thing, we have the square root of 64. What times itself equals 64? You should get 8. Now C is a bit tricky. I do ask that you memorize your multiplication tables up to 10 at least. And so 225, this isn't going to be on that list. So I recommend looking at the textbook and writing down the perfect squares that are listed there. This is kind of a challenge question. Do you know what the square root of 225 is equal to? Well, the answer is 15. 15 times 15 does equal 225. And finally, let's go back to something a little bit easier. Square root of 49. What times itself equals 49? The answer is 7. Now, one of the drawbacks to square roots is you do need to know your multiplication tables in order to find square roots. You can't just compute them. This is something that you have to know. There's no long procedure for finding them, you just have to know it. Okay, so now that we have exponents and square roots under our belt, go ahead and talk about order of operations. So when I first learned order of operations, I was taught, please excuse my dear Aunt Sally, or PEMDAS. There are other versions of this, but I won't mention them here because they're a little bit sarcastic. So what does Aunt Sally have to do with order of operations? So we're going to take the first letter of each word here, and it stands for something mathematical. So the P stands for parentheses. And parentheses, when we talk about parentheses, what we mean is simplify inside. It can't just be a number inside parentheses, it has to be some kind of operation. This also includes square roots, numerators, denominators, and as you progress through your math courses, this list will get longer. But when we say parentheses, remember that this is the main thing. We need to simplify inside. The E stands for exponents. Now in the previous slide we saw that square roots are very closely related to exponents, and they are in fact, technically they are exponents. You will see that in Math 120 if not sooner. But exponents, also square roots. So note here that we have square roots appearing twice. Remember that for the parentheses step, it means simplify inside the square root. So for instance, if I had something like the square root of 16 plus 9, simplify inside the square root, I would want to add. So that would be my parentheses step. Take the square root, it's equal to 5. This is my exponent step. So That's the difference between square roots under parentheses and square roots under exponents. Okay, I think that's enough with that. Okay, M stands for multiply and D stands for divide. Now please pay close attention here. This is very important. We do not always multiply before we divide. Multiplication and division must be done from left to right. In terms of the original or the first examples that we're going to encounter and called about order of operations, this is the most commonly missed thing. So hint, 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 this will show up on quizzes, it will show up on tests, because I want to make sure that you understand multiplication and division must be done from left to right. Okay, A stands for add, and B stands for subtract. Addition and subtraction, same thing applies. Addition and subtraction, we're going to see in the next module, are basically the same operation. And so we want to, addition does not necessarily take precedent over subtraction. This also needs to be done from left to right. All right, so let's go ahead and look at some examples. And let's see what we can do. So one of the things I encourage you to do when doing order of operations is to kind of make yourself a little checklist off to the side so that you don't go out of order. Okay, so if we have our checklist here, do we have parentheses in our problem? The answer is no. Do we have exponents? Yes, we do. That is the first thing that I want to go ahead and evaluate. So 2 squared, this is 2 times 2, and 2 times 2 is 4. From there, we have addition. Now, as everything here is being added, we can go ahead and add in any order that we want, because remember, addition is commutative and associative. So if we go ahead and add 4 plus 5, we get 9, plus 4 equals 13. All right, let's go ahead and try another one. Let's look at example B. This is actually the way I write, like writing PEMDAS, is so that this way I remember that multiplication and division are done at the same time, as well as addition and subtraction. So, do we have parentheses? The answer is no. Do we have exponents? No. Do we have multiplications and divisions? Yes, we do. Now, what do we do first? Now I'm going to do this problem wrong to start off with. I'm going to pretend that I believe multiplication is always done first. If we do our multiplication first, we get 35 divided by 30. And all of these you should be able to do without a calculator. You should be able to write your answers without remainders. And it's just the way the problems are built. Right now, does 30 divide into 35? The answer is no. And so this should send out big warning signals that something has gone wrong. Okay, it does not divide evenly. So let's go ahead and do this problem the way it should be done. Remember that multiplication and division must be done from left to right, which means that I want to divide first. 35 divided by 5 is 7. Bring down our times 6. And 7 times 6 is equal to 42. All right, let's keep going. Example C. We have 3 squared plus 2 cubed. Okay, do we have parentheses? No, we do not. We do have exponents. 3 squared is 3 times 3, which is 9. 2 cubed is 3 2's multiplied together. If we multiply, 2 times 2 is 4. Times 2 is 8. All right, that takes care of exponents. Do we have any multiplications or divisions? No. And then do we have any additions and subtractions? Yes, we do. We do them from left to right, and actually we just have an addition here. So 9 plus 8 is 17. All right, that takes care of example C. Let's come up to example D. So again, do we have parentheses? No, we don't. Do we have anything that counts as exponents? Yes, we do. It's not an exponent, it's a square root, but that still counts under our exponent step. So we want to go ahead and evaluate the square root. What times itself is equal to 36? We should get 6. All right, multiplications and divisions. We have some divisions in this problem, and we want to go left to right. So 60 divided by 6 is 10. 10 divided by 2 is 5. All right, let's go ahead and look at example E. Example E. Do we have parentheses? Yes, we do. So we're going to start with that. This does count as parentheses. We do have an operation inside. So if we go ahead and simplify inside parentheses, we get 6. 14 divided by 2 is 7. Do we have exponents? The answer is no. Do we have any multiplications or divisions? Remember that if you have a number inside parentheses and another one outside it, that is a multiplication problem. So this does count as multiplication. That is my next step. 6 times 7 is 42. And finally, additions and subtractions. 8 plus 42 is 50. Okay, let's go ahead and look at example F. Example F, we have 12 minus 6 plus 4 squared. We do not have parentheses. We do have exponents, so I'm going to start with that. 4 squared, this is 4 times 4, or 16. We do not have any multiplications and divisions. That leaves my additions and subtractions. And remember again, addition and subtraction must be done from left to right at this stage. So do not add 6 and 16. We want to start with 12 minus 6. 12 minus 6 is 6. 6 plus 16 is 22. All right, just a couple more. All right, let's see what we can do for example G. We start with parentheses. We have inside the parentheses 5 minus 3. That becomes 15. All right, we do have exponents on this problem. 2 cubed. We looked at this earlier. 2 times 2 is 4, times 2 is 8. 3 squared, 3 times 3 is 9. And we'll bring down our minus 15. We do not have any multiplications or divisions, so we're going to go ahead and look at additions and subtractions. So addition and subtraction from left to right, we're going to start with 8 plus 9. That is 17. And 17 minus 15 is 2. Okay, we got 2 more. All right, so example H. We do have parentheses, so let's start with our 7 minus 5. We get 2. I'm going to go ahead and remove the parentheses now. I don't need them anymore because we don't have a number in front. It's just a plus sign. Plus 2 is the same thing as plus 2 in parentheses. Okay, do we have exponents? The answer is no. We do have some multiplications and divisions. We have a division here. 20 divided by 2 is 10. And finally, we have our addition. We get 10 plus 2 equals 12. All right, last problem. We do not have parentheses. So we're going to start with our exponents or our square roots. So if we go ahead and take square roots, we get 15. Square root of 9, what times itself equals 9? The answer is 3. Minus 8 times the square root of 4. What times itself equals 4? That is 2. That takes care of our exponent step. Next thing we have is our multiplications and divisions. 15 times 3 is equal to 45. 8 times 2 is 16. And just because I'm a little bit tired, I'm going to go ahead and make sure I do this correctly rather than try to do it in my head. So I'm going to borrow from the 4, turn the 5 into 15. 15 minus 6 is 9, and 3 minus 1 is 2. So we get our final answer of 29. All right, that takes care of order of operations. Now this is something that we will revisit when we talk about each one of our operations. And you will see this continuously throughout math. Every semester you will be talking about order of operations. So at this point, just take your time on these problems. Make sure that you are following order of operations perfectly. Do not try to combine steps, though it can be done. I do not recommend doing it. It's more important to wait and see what happens as you progress through the problems before you start trying to multitask. Okay, so that takes care of this section. We got one more section and then we'll be done with this module.